And the first question on today's daily math asked you to order the numbers 287,901, 287,982, and 287,099 from greatest to least. What does greatest mean?
The bigger number.
The biggest to least means
Bigger to smaller.
biggest to smallest. Greatest is the largest, least is the smallest. So if I look at my three numbers, they all three have 287 thousands. So does that help me to order them by looking at those three largest place values?
Yes.
No, because they're all the exact same. So where am I going to go from there to figure it out, Caden?
You're going to go from there.
If my 100,000s, my 10,000s, and my thousands are all the same, what do I look to next? Look to the hundreds. So I have 900s, 900s, and 0 Based on the hundreds place value, what do we know?
We know that they're different.
One of them's different. So what does that tell us if I have one that's different? What do I know about that one that's different?
It's lower. I mean, it's greater than all others.
Harper, what do we know?
It's the lowest. It's the smallest number.
Yeah, it's the smallest number. It has 0 so it's going to be the smallest. We know that's going to be the last number. All right, so we know that 287,099 is the least number. We still have to figure out which is the greatest. So both have 900s. So that doesn't help us. What do we do to figure out next, Caden? We're going to the tens. So I have 0 tens and 8 tens. What does that tell us?
That 92,287 is more.
8 tens is more than 0 tens. So I know that this is my greatest number. This one is in the middle, and then of course we've already figured out our least. So 287,982 is the greatest. 287,901 is next. And then 287,099 is the least. So the correct answer is the last choice. Next, we're writing the number 7,080,267 in expanded form. Look at the first choice. What's wrong with the first choice, Ansley?
It says 700,000.
Yeah, this says 700,000. I don't have 700,000, I have 7 million. How about the second choice, Dylan?
It has 7 million.
It does have 7 million. How about the others? Are they correct?
No.
What's incorrect about the second choice?
The 80,000 is only an 8,000. It's a
Ooh.
10,000 off.
Look at 80,000 at this 8 digit in our number. What place value is that 8 in?
80.
Yeah, it is 80,000. So does the second one. So we have 7 million. We know that's true. We have 80,000. Is that correct? Yeah, that's correct because the 8 is in the 10,000s place value. Is 200 correct?
Yeah.
How about 60? Yes. 7?
Yes.
Yeah, so the middle choice is correct. Okay. Oh,
That's what I was saying.
okay. Well, I was asking about the second one.
I was trying to say the bottom one has 10,000
Okay.
off.
Yes, the bottom one is the 8 is in the wrong place value. It's 8,000 instead of 80,000. So that's what's wrong in the last choice. All right, moving on. Round the number 9,372,282 to the nearest thousand. So if I'm rounding to the nearest thousand, I'm going to go to my thousands place value. What digit is in the thousands place value, Amy? 2. I'm going to underline that thousands place value and everything bigger. So really I have 9,372 thousands. So we're keeping everything larger than the thousands place value. Where do I look to see if my thousands is going to round up or stay the same, Amy?
The hundreds.
I'm going to look to the hundreds. What does that nosy neighbor 2 make your thousands place do?
He tells the other two stay the same.
To stay the same. It's less than the midpoint, less than 5, so it stays the same. So my 9,372,000 all stay the same. What about the rest of the number, Amy?
You keep the same.
I've got the numbers that I keep to my thousands place value. What do I do with my hundreds, tens, and ones?
You make them to 0.
They all become zeros. 0 hundreds, 0 tens, and 0 ones. All right. Next question. There are 4,389 dogwood trees in the state park. The park workers are going to plant 342 more trees. How many trees will there be when they are done? How am I going to solve that one? If we know how many trees there are, and the park workers are going to plant 342 more, I want to know how many they're going to be when they're done. So what will I do, Christopher?
You add them.
I'm going to add them together. 4,389 plus 342. Where do I start, Christopher?
9 plus 2 is 11, so you have to carry it over and put the 1 down.
Okay, I'm going to put my 1 1 and carry my 10.
And 9 and 4 is 9 and 4 would be 13.
9 plus 4 is 13.
And you carry over.
Okay,
And then 4 and 3 is 7.
good.
And then you take the 4 down because there's nothing left.
Okay, so my answer is 4,731. There will be 4,731 trees in the state park when they are done. Next, we're finding the product. 5,694 times 5. How are we going to solve that one? What can we do to multiply that big number? Harper, what did you do to multiply?
Well, I got the answer wrong.
Okay. So let's see if we can figure out how we could fix that. What would we need to do to multiply?
Well, you would multiply 5,694 times 1 and we'll add that number again.
Okay, so we could use repeated addition and do 5,694 plus 5,694 plus 5,694 plus 5,694 plus 5,694. We could add that 5 times. What kind of multiplication strategy could we use that would be more efficient, Ansley?
Well, I got this wrong, but I know how
Okay.
to do the strategy. So you have to do 5,000 times 5. And then you take, then circle both of the 5s and do 5 times 5.
Uh-huh.
And 5 times 5 is, it's not really hard.
Mm-hmm.
And 3
3 zeros at the end. Perfect. Okay, what's next?
I'm then with the 600 times 5.
All right. So 6 times 5 equals
35.
30. So I'm going to write down my 30.
And
2 zeros. I want everybody to stop right here for just a second. I did 6 times 5, which was 30. And I was really multiplying 600 times 5. Why do I have 3 zeros in my product instead of just 2, like in 100? Why are there 3 zeros?
30, and then you were taking the 2 zeros that you had from the 100 and adding it over.
Exactly.
The 6 5s
Because,
like a 10.
yeah, 6 times 5 equals 30. So I had a 0 in that product.
And then you had
Then I added my 2 zeros. Okay? Okay? It's kind of tricky if we don't really stop and think about it. All right, sorry, Ansley, I kind of messed up your train of thought there. What do I multiply next? 90 times 5.
How does this every time someone walks back?
So 9 times 5 is 45. How many zeros do I have? 1 0. So 450. Then we have 4 times 5 equals 20. Perfect. And then I'm going to add all those together. 0 plus 0 plus 0 plus 0 is 0. 0 plus 0 plus 5 plus 2 is 7. 0 plus 0 plus 4 is 4. 5 plus 3 is
8.
and 2 plus nothing is 2. So my answer is 28,470. The product of 5,694 times 5 is 28,470. Next, I'm finding the sum. What does find the sum mean, Owen?
Find the answer once you put it all together.
Put it all together by adding, and I'm looking for the answer.
The answer to addition.
The answer to addition. And when we add numbers together, that gives us a total. Okay? So 8,534 plus 43,756. So I'm going to write those down. 8,534 plus 43,756. Did I do that correctly?
No.
What's wrong with it?
You put the 6. You're supposed to put the 4 above the 6.
Yeah, we have to match our place values. But look at our problem. The first add-in, or the first number that I'm adding, is smaller than the second. Does that matter? Is that okay?
No.
That's okay.
Is it? Why do you think it's okay?
Because anything with adding is okay.
Yeah, it doesn't matter when you add. I can add in any order. So what if I don't like it that way? What if I want to flip-flop it and put my biggest number first when I add it? Is that okay?
Yes, it's still okay.
Yeah. What if I want to add the smallest number first on top? Is that okay?
Yes.
Yeah, doesn't matter. Either way.
But with
But,
subtraction, you can't.
Right, with
Like
subtraction, we can't.
1,000 minus 8,000.
Yeah, you cannot flip your numbers in subtraction,
That'd be
but you can, right, you can in addition. So it does not matter which number I put on top, but I have to make sure that my place values are lined up. So I'm just going to write it the way that it's written. I'm going to write 8,534 plus 43,000. Why did I move that 4 over? Why did I move it over?
Because it's in the 10,000.
Yeah, it's in the 10,000s place value. I don't have any 10,000s in my first number. So my thousands are lined up. My 700s are lined up with the hundreds. My 5 is lined up with the 10s. And the 6 is lined up with the 1s. So I have 4 1s plus 6 1s. What does that equal? What's 4 plus 6?
10.
10. I'm going to write down my 0. What do I do with the 1?
You put it above the 3.
Put it up above the 3. 1 plus 3 is 4, plus 5 is 9. 5 plus 3 is 8, and then we had one more to add. So that equals 9. Then we have 5 plus 7 is 12.
So you put that 1 above the 8.
Perfect. I'm writing down my 2 and regrouping the 1.
And that would be
12.
Very good. 1 plus 8 plus 3 is 12.
And then 4 plus
So
1 is
2.
5.
I'm carrying my 1, and 4 plus 1 is 5. Very good. So the sum is 52,290. Okay.
I didn't get this. I didn't get that.
Now we've got a couple of division problems. 74 divided by 3. So there's a few different things that we could do to figure out. Could make 3 groups, and I could give each group 1 until I got to 74 and see what happens. But 74 is a whole lot of 1s to give out, isn't it?
Yes.
Okay. So is there anything that you notice about the relationship between 74 and 3?
That one.
Caden, you notice anything?
Wait, what'd you say again?
Anything that you notice in the relationship between 74 and 3? I've got 74 things total, and I'm dividing them into 3 groups. So is there anything you notice that might help us to divide? Ainsley, do you notice anything?
I just wanted to point out that maybe, because like maybe the reason we have like the R's and stuff
Mm-hmm.
is because 74 is an even number and 3 is a
That's a good point. So 74 is an even number, and Ainsley said 3 is an odd number. So that's probably why there's going to be a remainder. Okay? So, or the R, or the leftovers. So let's think about this. I have 74 things in total, and I have 3 equal groups. So let's just make 3 equal groups. 1, 2,
So it's really like
3. Yes.
the remainder mean like how many is left over?
How many's left that would not go into the groups equally? Yes.
So like 22 divided by 7 would be 3 with a remainder of 1.
Exactly. So, do we want to go by ones? Do I want to start going 1, 1, 1, 1, 1, 1, all the way to 74?
No.
What do you think we might could start with?
Please. 10.
Ooh, why would you want to start with 10s, Kaden? I like your idea.
Because I would put 1 in each box until I get to 7, and then I would go ahead and put 4 more in there.
Okay, so if we did 10, 10, and 10, how many of these 74 have I used?
3.
I've used 10, 20, 30. That's a lot quicker. I just got to 30 just like that.
So 4 more.
Okay, so I've got 40 more. So could I give each group a 10 again?
Yeah.
Okay.
But one group would have 1 more.
Okay, so we've got 10, 20, 30. If I give another 10, that gets me to 40, 50, 60. I have 74 total. I've used 60. So can I give another 10?
No.
No? Okay. So what do you think we might want to start with now? What are you thinking?
The 4.
Ones? Okay, so we're at 60. 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74. Uh-oh, I ran out. Do I have equal groups?
Nope.
Mm-mm.
You have 25 in each group.
How many are in each group?
25.
Ooh, do
Except the last one.
I have 25.
25.
I have 25, and my last group has 24. So can I put 25 in each group?
No.
No, I can only put, how many can I put in each group?
20.
24.
Huh? That's the remainder of 1.
So if I have 24 in each group, what are we going to do with the extra from these two?
24 with a remainder of 10.
Yeah, I've got 2 left over. I have 1 left. Let me change colors so we can see it. I have 1 left over here. I've got to kick it out. So there's 1 remainder.
And then there's a second.
And I have another one here that I'm going to have to kick out. So I can put 24 in each group, and I would have 1, 2 left over. So 24, remainder 2.
I got that one wrong, but I got that.
Okay.
I got that one wrong.
Okay. That one was kind of a challenge problem. We haven't really worked with numbers that big. All right. Let's check. Let's do 337 divided by 3. What strategy do you think we could use for that one? Could we do something similar that we did here?
Yes, I put 3
We
groups.
could. Okay.
I put 3 groups.
You put 3 groups. All right, we can solve it that way.
3 groups of 100.
Ooh. Dylan says 3 groups of 100. Why would you want to take care of that 100 first?
So we can close the top out of the way.
Yeah, we can get it right on out of the way and quickly. So 100, 200, 300. How many do I have left?
37.
37. All right, so what are we going to give to each group this time?
10.
Ooh, why would we give 10?
Let's say you can pop them 10s out of the way.
Yeah, so 310, 320, 330.
Now you'd have to go with 1.
Now how many do I have left?
7.
7. Only got 7 left. What are we going to give to it this time?
1.
Ones, okay. You can do it by 1. So 331, 332, 333, 334, 335, 336, 337.
It's the remainder with 1.
All right, so swap colors. How many are in that first group? 100 plus 10 plus 3 is going to be
113.
113. How many are in the second group?
112.
112. And the last group?
112.
112. So how many do I have in each group?
112.
There's 112 in each group. This one has an extra. So I've got to kick that extra out. And that's the remainder of 1. 112. Remainder 1. The last choice is the correct answer. All right.